Good afternoon. I was hoping you would be delayed for lunch or you would eat a lot, but okay, let's see if it works. Yeah, today, so on Tuesday, I gave a 15-minute talk. It was actually not even meant to happen, but that spot opened, so I did that, and it was a sort of a teaser for this session. And here at SATURN, of course, it's a conference about architecture, so we see a lot of concepts, a lot of good ideas. We discuss patterns, and rarely the case we get to see things running. So this session will be slightly different from most in that sense, because we are going to try to make some of those ideas real. And this is TCU, so I work at the floor level of this building. This is a campus with 5 buildings. If you're ever in Brasilia, let me know. I'll give you a tour. So this is the agenda. I'm going to say a little bit more about architectural conformance. By the way, quick show of hands, who was there on Tuesday when I gave a 15-minute talk about this? Okay, great. So I don't have to repeat much. And then we're going to do a custom checks lab. Those of you who have a computer are invited to participate. If you don't, that's okay, because I'll be doing everything here on my computer. Not every day that I get a chance to code standing up. Let's see how does that go. Then I'm going to talk about sonar cube analysis. And I'll close with some remarks about our experience with this approach back home, okay, and some lessons learned. Now, before we actually get to the lab, for those of you interested in doing the exercises, to save time, here's an idea. You can right now open on a web browser this website here, dontpad.com. Anyone here familiar with DontPad? Okay, it's a nice, very simple website. Let me open it here. So just type dontpad.com/Saturn17. And you're going to see, you're going to find exercise 0. That's what I want you to do right now. And the first step is to download CheckStyle, the jar file, okay? You can just download it from this URL. And by the way, look, this on DontPad, you all get to edit. This is shared notepad of sorts via the web, okay? There's no control. If you want to, do this, then you're going to get me in trouble. So please don't do that. Of course, I have my backup here, risk mitigation. But anyway, so try to download this to your machine. In the other commands down below, I have assumed that CheckStyle, for example, is going to go to this directory. Now, if you're using Linux, and I commend you for that, first off, I apologize because I didn't get the commands for Linux, but feel free to do that, okay? You can actually write them down if you want, and I didn't think of this. I just copied and pasted from where I was, but yeah, /dev on Linux won't work well, so you're probably going to go to /home/Saturn something, and then you download things there, okay? So one thing is CheckStyle, the jar file. And the other thing is we have 2 Java projects that I'm going to play with. One is like the target code base that we're going to analyze, and the other is our project with our custom checks. Okay, so here we have step 2 and step 3 to download these 2 projects. If they're on GitHub, P. Merson, and if you have a GitHub account, you may want to fork the project, and then you may push them back when you write your solutions. If you don't have Git, and if you don't have Git on your machine, you can just download the zip file and expand it. And if you don't want to fork, you can just git clone. So those of you with laptops on, You already accessed Saturn, don'tpad.com/Saturn17, I hope so, and start the download. They're very small. I hope the network connection is fine. So, but we're going to get to that point. And all you need on your machine is Java 1.7. If you have an IDE, probably will work better. I'm going to use Eclipse, and at home we use Eclipse or IntelliJ, so I have been using Eclipse since 2002. I actually wrote several Eclipse plugins, so I have an emotional connection, I guess. But okay, so we talked a bit about architecture conformance on Tuesday, and this is again just a repeat. There are consequences when we create code and we don't pay attention to architecture conformance. Over time, this happens with bigger projects, of course, as we're going to see next. But the main issue is maintainability. The code becomes hard to maintain, hard to evolve, right? Basically because of the undesired dependencies. But lack of conformance can hurt other quality attributes as well. So I mentioned portability on Tuesday. It may hurt security. Sometimes you create, let's say you're doing REST. You're creating REST using Spring MVC, and you're writing REST controllers, and you establish as an architecture design constraint that your REST controller classes need to be configured with something for security. If someone creates a REST controller that doesn't follow that design rule, it's negatively affecting security. So that's one way. So how do you prevent that? Custom checks can help, as we're going to see. Factors that influence architecture conformance. So, of course, how effective the architecture documentation is. More effective, less lack of conformance you're expected to see. Turnover among developers. If you have too many people coming and going, it gets hard because the way it goes, you join a project and it takes sometimes weeks and months for you to get a hold of the forest. Okay? At the beginning, you open your IDE, and oftentimes I joined projects and they said, hey, here's everything you need to know about our software project. We already have some tickets assigned to you, and what they give you is the URL to the Git repository or the Subversion repository. You open the code and you only see one tree, two trees. It takes a while for you to see the forest from the tree. Haste to fix bugs or implement features. Sometimes they kind of end up, their incentive for you to introduce undesired dependencies. Size of the system, bigger the system, more important architectural conformances. Distributed teams, this is not very obvious, but a lot of communication, and this is not me saying, people have studied this, a lot of communication across the team is verbal. And when you have this geographically distributed people in the development team, it's much harder to get a collective view. Accountability for violating design constraints as well. So how do we avoid code and architectural disparity? One thing, as I mentioned on Tuesday, is to communicate the architecture to developers, but we're not going to go over there. I just have 3 bullets, very important things. Of course, quick plug, shameless plug. This is a good book Pierre mentioned you can get to solve that issue. There are different things you can do. Another thing is to automate architectural conformance analysis. And I have tried different strategies, tools. Even when I was at the SCI many years ago, I wrote a report, a technical note about using AOP for this, right? And having tried so many things, and in Brazil I am at a position that we need to do that. It's part of the job. I found, so far in my experience, the solution that has worked the best. It's simple enough and powerful enough. It doesn't cover all bases. There are many architectural constraints that you can't simply verify or enforce. Enforce is a tough word, but with this kind of solution. But it goes a long way, right? And the idea here is to create custom checks using static analysis tools, and I listed here 3 that we have used back home. For this tutorial, I'm going to use CheckStyle. Okay, so and again, something I mentioned on Tuesday, these tools come with several built-in checks, and they are fantastic to raise the quality of the code in your projects. Jen Campbell gave an excellent talk last night, and she was saying things, and I was so glad to see that. I want to show them back to people back home, because we have adopted SonarQube analysis about 6 years ago, and we saw that kind of tidal wave across the projects. All of a sudden, all the projects, all the main Java projects, corporate projects, were being analyzed, and we actually had like our not nutrition facts, but we have a quality index. We fine-tuned the quality index that comes with SonarQube to our own, the things that we thought more would be more important, and then all the projects now had a score. We had a calculation of technical debt, and there was an influence across the projects. We had, at some point, we got big screen TVs across the development floor, and managers in meetings began to talk about the score of their projects. So that helped to move everybody up and into that mindset that you need to clear the bugs, clear the major issues, don't let blocker issues pop in, and so on. But these tools, as they come with, when you download, these checks they're limited in terms of enforcing your architecture. They don't know your layers, they don't know your architectural elements, your naming conventions, right? But some of these tools give you an API, and then you can create small programs that can do that for you. So that's what we're going to do today. And these programs are the custom checks, aka custom rules. All right, so we're going to use for the lab here, the quick lab, CheckStyle. This is a free open source static analysis tool. It has a Java API, quite mature. It uses the visitor pattern, one of the 23 Gango 4 patterns. And one nice thing is that the API gives you access to the entire syntax tree of any Java program. This is the old logo and the new logo. So I have this silly animation here, just a reminder that I should go over here. So I have here Eclipse, and did anyone download the files from that indicating as in Notepad? Anyone? Did it work? Got CheckStyle? Anyone? Huh? Oh, okay. No. So here on Notepad, we have exercise 0. The idea is just to download these 3 files. One is the jar file for CheckStyle, and the other 2. Did anyone get to do that? Okay, great. So we have here the custom checks project. If you have an idea, you may want to import that project there. It's a Maven project, by the way. And I have one package, tutorial.checks, with the checks we're going to play with, okay? And there's this other project called Adventure Builder. This is going to be our target code base. It's a legacy application, old code, okay? So at this moment, I want to ask you, those of you with the files already downloaded, to try to follow the steps for exercise 1. So just go to notepad.com and you're going to see them there. Question?
How do you make the view in CheckStyle bigger grow?
Where?
Very small. Defined, super small.
Oh, here in Eclipse?
No, I do CheckStyle. I render it exercise font. But everything's super small. Just like way bigger, but I put the font.
So what's exercise 1? One thing that we have in CheckStyle is a nice GUI program that shows the abstract syntax tree of a program, okay? So let's do that. You just run this class here, GUI.main. You can copy and paste. And then step 2 says, click the open file at the bottom. It's this thing here. So we can open a file. And I handpicked a source file in our target code base over there. It's called errormapping.java. All right. So this is the program down below. And here we have the syntax. So the first statement is a package declaration, okay? And it's a tree, so you can double click it, it's gonna expand. And on the second column, you see the token type, okay? These are actually names in the CheckStyle API. There is a token types class or interface that has all of these constants. So package definition, then we have within a package definition, have annotations, etc. Then we have import statements. There are 2 import statements, and then there's a class definition. Of course, if here, once you open the class definition, you're going to find the name of the class and everything. And as you click through, you can see here the tree. You can see what's the token, and you have the line number, even the column number, and the text in the program, right? And the actual class block is down below, so it's expandable. This tool is very important when we're writing custom checks, because we're going to enforce these architectural rules on the syntax of our programs, okay? So exercise 1 is just that. Make sure that the GUI is working. Did anyone get to run it? Did it work? Okay, great. Okay, yeah. I can't give this to you because otherwise I can't run it. Oh, you can open. Look here on down. Where is it? You can open this file. Click Open File at the bottom, and you can copy and paste this line here, and you can open errormapping.java. If you have downloaded these files to a different directory, then you have to translate here in the commands on Notepad. By the way, feel free to do this, like open Notepad, type your name, and then you have another page. Oops, this name already someone picked. There you go. Really? Let's go ahead of time. There you go. That's an empty page. And then you just copy everything from here, Control A, oops, Control C, and then Control V, and you can mess up with this one, okay? Okay, our target code base is an application called Adventure Builder. This is a Node J2E application. We used it in the Documenting Software Architecture book, as a companion to the book, there are approximately 14,000 lines of code, and the project is not Mavenized, so I can't quite build it as is on my IDE right now, because I simply don't remember how to run Ant builds anymore. Anyway, but the nice thing about Adventure Build is that the architecture is documented. We created a wiki back then when we wrote the book. Okay, so what about CheckStyle? How does it work? Well, there's that GUI program that shows us the tree. That's one program, but the main program is the analyzer. What does it do? It's this class here, class main, not GUI.main, but just main. So it parses the source files in a loop, okay? Internally, it uses Antler. And then there's a configuration file where I indicate what checks to run, okay? CheckStyle comes with several built-in checks, but here we're going to run our custom checks. And then it's going to loop. So I got a file to process. It's going to loop for each token in that file, that source file, and we'll call the custom check. Call what? A method called visit token. So it's going to start with a package declaration, import statements, and so on and so forth, right? So does it mean that when you're writing a custom check, you need to pay attention to all of these tokens? No, it's very optimized. You just indicate, I'm interested in this token or this other token. Oftentimes, you write custom checks, you're going to be interested in one token alone, 2, 3. If it's a complex custom rule, you're going to be interested in 4 tokens, okay? And then it loops. And in here, when we are visiting a given token, you may find the violation right there, and then you just issue the violation in the code, and that gets reported back to CheckStyle, and CheckStyle reports it back to the user. As this is the command line. It will report it in the std out, excuse me. And you may ask, well, where is the analyzed file in this diagram, this simple sequence diagram? The file that we are analyzing is just a string. It's just input to the processing. It has no role in the execution here, of course, okay? All right, so let's try our first custom check. It's a simple usage dependency rule. So here's the rule. Code in a given package called process manager. You could imagine that process manager were like a layer, okay? Cannot use code in another package called OPC. It stands for Other Processing Center, I think. Here's the diagram, the original diagram, the architecture documentation. So the rule, the design constraint there is that code that lives inside this package cannot call code that lives inside the big package here, which is OPC, all right? When you have a rule like that, first question, how can you identify code that belongs to process manager? Package namespace. So if you organize your source code, well, process manager is the name of the package. It means we need to look at package declaration. So we already know that that token is of interest. How do we identify use of modules that belong to OPC? If you're in a Java program, how can you tell this program is using something from another package? The most direct way is looking at what? Imports. So the import statements up on top, they show other packages that or classes that we are interested in. So we're going to take a look at package declarations and import statements. These are the 2 tokens of interest, right? And hence that's the answer to the last question over there. All right. So I have here this check. It's called check process manager calls OPC. That's what I'm looking for. Process manager calling OPC. That's the violation. Is it readable? You can increase the size. Where do I do that? Yeah, I don't know how to change the size here. Does anyone know? Is it readable? Sorry about that. Anyway, look. This is a custom check. It extends custom check. Custom check is a superclass that I have here already in this project with several convenience methods. And if you start from scratch, you're going to extend CheckStyle check. That's the superclass. I have some convenience things there. So what I do is I define a violation message. This is the error message to the developer. And the violation message says, classes in Process Manager should not call classes in OPC. Okay? And then I have this standard method here, get default tokens, where I indicate what tokens I'm interested in. In this case, it's package definition and import. All right? How do you know which ones? How do you know the name here? Then you go to your AST tree. So you look at, oh, this is the package definition. What's the name? Here it is, package-o_def. Import, so here's an import. There you go, it's an import token type. Okay, so this is the class that has all the tokens, token types. And you only need to write one method, visit tokens. Visit token follows the visitor pattern. And this is the method that the CheckStyle engine will call on your custom check. And it will call only when it finds a package definition or an import in this case, right? So that's why typically you're going to have an if statement to check the type of the token here. So if it's a package definition, and here's the logic, how do we implement that rule, okay? I get the package name, okay? I found a package declaration, so what's the package name? Well, here, I simplified things. I have a method, a convenience method in the superclass called fully qualified package. I give it a token for a package definition, and it gives me the full package name, okay? So I can then check if this package name starts with, and this is the full package, by the way, process manager. If it's process manager, it means I found a class inside that process manager package. The obvious. Thank you. So if I found a class and I know it's inside process manager, I need to set this variable. Why? Because I'm only processing the package declaration, okay? And then I'm going to return control back to the CheckStyle engine, and it's going to keep parsing. And then when it finds an import, then I need to know, was I inside a class inside process manager? That's what we're doing here. So we set it to true or false, okay? And you may say, but this is an instance variable here, a member variable. You don't need to initialize it to false. It's already false by default. This is a detail of Java programming. If anyone is a Java certified programmer, probably knows that. But in this case, you do, because this is, you may be running CheckStyle to analyze thousands of files. And by the way, it is amazingly fast. We analyze a custom check like simple as this. We can run it on 10,000 classes in about 2 minutes. So you need to set it to true or false. And then it keeps parsing, and then it finds an import statement, okay? And then you see, okay, I found an import statement. Am I in a process manager class? That means, am I in some piece of code inside that process manager package? If the answer is yes, then you can further check. Okay, I found an import. I am inside process manager. Is this an import of OPC? If it is, there you have it. You found a violation to your design rule. And then you use just this call log to generate the violation, okay? So it is that simple. So where am I? Now it's your turn to play with it. How do you run the custom check? Well, we just call in the command line Java. So if I go to Notepad And I'm going to ask you guys to do exercise number 2, which will go through, the first step is to run the custom check as is, and then I'm going to ask you to improve the check. How so? There's an additional rule. Actually, it's an exception to the design constraint. The exception is process manager cannot call OPC except for this subpackage utils, which actually you can see here. So process manager can call package utils inside OPC. So there is an exception to the rule. And then there's homework assignment. If you guys want to play further with this, check for static imports and check for references that don't use import. The Java programmer, and you will remember that you don't need to import a class if you reference it with a fully classified name. But for now, we're going to assume it's being imported, and we need to do that, create that exception. So in Don't.pad, we have here exercise number 2. And the first step says, make sure the declaration of our custom check in checks.xml is uncommented. Checks.xml is that config file. It's right here in the source main resources. That's where I list the checks that I want to run. Okay, so we have 2 checks. I'm going to comment the second one for the moment, but if you clone the project, they might be both commented, so you should uncomment the first one. And then let's build the project. So I'm going to open another prompt here. I'm going to leave the tree up there. First time is always good to do -u when you're building so you can bring whatever you need, but in this case there's nothing to bring. But Maven, I'm building the project. If you don't have Maven on a command line, it may work on the IDE. Build success. Then I go to Don't.pad, and it says, make sure the initial version of the custom check works fine. So this is the command line. It looks pretty long. We don't usually do this on the command line. You do it on the IDE, but I wanted to get like the simplest technology stack here to make it work. Oh, yeah, this is everything. So what I'm doing here is I'm just executing the CheckStyle engine. It's going to look for custom checks.xml. That's the config file. And I'm indicating the target code base, okay, which is this. The last line, actually. The last line is the target code base. It's my Adventure Builder project, but only all the way to this subdirectory here called transitions, okay? If you indicate a subdirectory, it's going to check all the files from that point downwards. So there you go, and it says starting audit, audit done. It didn't find any violation, okay? And then we have step 4. It says this previous command ran on the transitions subpackage down there. Let's try to run this on the entire Adventure Builder project, which is all of the 14,000 lines of code. So I'm just going to copy. Yes. You can stop it, the last path name, you can stop it at Adventure Builder. And here, starting audit, and he found an error. The error is reported like this. There's the name of the file, which is awfully long here because of the path name. And then there's the line number here. And then the error message saying classes and process manager should not call classes in OPC. Okay? And in square brackets, you see the name of the check that issued that error. So the execution gave us an error. This error is because there is a call in that class towards the utils package, and So in that case, you would check that code and oh, this is a false positive because calling utils is okay. So the next step is to edit the custom check to allow calls to the utils package. So the exercise says, as a second step, you can even further refactor this method to things more, make the code more clean. Let's try to do that. So I'm going to go back. Here's visit token. And we know we found an import. And we know it's an import to OPC. But if it's opc.utils, it's okay. So the only thing I need to do here is what? It can start with OPC, but it cannot start with opc.utils, correct? So that's pretty much it. Refactoring. Yeah, this method is already too long. Martin Fowler would call it a smell, so let's fix it. What I usually do is I have one method for each token. So you just go here, refactor, extract method. I'm going to call this visit package def. And this one, refactor, visit, import. So now it's cleaner. But does it work? So let's build it again. Well, no syntax error at least. And this is the execution on the entire Adventure Builder code base. Remember, it was issuing an error and no longer issues an error. So that exception is already in the code. Okay? This will be a common situation. You have these overall custom rules, but there are known exceptions. You may not even like them, but you don't want to fix them. Sometimes it's legacy code, so you just code in. All right? Moving on to a different kind of custom check. Check for a mandatory generalization. That's a quite common situation as well. And in here, Adventure Builder, we have that. So this old application, remember it's a J2EE application, uses a web framework called WAF. In this framework, there's a special architectural element, which is the HTML action, which is a class that handles HTML actions, okay, on a web page. So we can say that HTML action is a special type of module. So oftentimes we create an architecture, we have these architectural elements, right? So you're using a style that you got from a catalog, or you create your own style, and styles specify types of elements. So sometimes you have controllers, sometimes you, for example, MVC, it establishes, oh, this is a model module, this is a view module, this is a controller module, this is a DAO. In this case, HTML action is something special, all right? And we have this rule. All HTML action classes must extend HTML action support. Why is that? Because I suppose I created a superclass that has some constraints, that has some common code, maybe security controls, okay, that I want to exist in all of my HTML actions, okay? And then you have to ask a question, how can we identify an HTML action module or a class, okay? How can I identify a controller if controller is something important? How can I identify a class that is part of the model? How can I identify a class that is a DAO? Okay. Here's where architecturally evident coding style is important. Actually, it's essential. The code should make the architecture visible. Elements in the code, we're going to write, say, 100 classes. A few of them will have more architectural significance. Others will be just auxiliary code around these important architectural classes. Okay? How do you do this in practice? In Java. Similar to other languages, but in Java, basically you're going to create naming conventions. For example, for your HTML actions, you can say all of my HTML actions should have the HTML action suffix. By the way, this is the convention used in J2, in the Adventure Builder application. So we're going to use that one. But it could have been an annotation. In our architectures back home, we have several annotations for entities, for special services, for domain services. We use a little bit of DDD, so we have something called @DMS. And we know, okay, this is a domain service. So there are some constraints there. What can it? These are custom annotations that we created. They're not for the custom checks. They have significance in the code, but they are useful for the custom checks because we can check the rules, spotting. We can spot a domain service class because it has @DMS. A package namespace, of course, is important. It could have been like everything that is under actions, right? And also superclasses, interfaces, and even comments. Some of these static code analyzers can pick code or pick comments and parse the comments. CheckStyle can do that. And at this moment, let me say a little bit more about the API, okay, the CheckStyle API, and you're going to see how simple it is. So remember the tree, right? You can access with the GUI program. It's a tree of tokens. There are like keywords, there are literals, okay? There are all sort of things there. But basically it's a tree. So the methods to work with are basically methods to navigate that tree. And you remember visit token. That's when the CheckStyle engine will give you a token. So you have a method get first child, one that gets the next sibling in the tree, one to get the parent, one to get the previous sibling. Here's a very useful one. Find the first token with a given type. So you're going to find the first child that has that specified type. So if you're in a method declaration and you want the first parameter, and you ask, give me the first child that is a parameter. Get child count, often the case you want to see, hey, how many parameters I have? And then you have 10 parameters, that's a smell, and you point that out. Get child count of a given type, yeah, that's the case. So this is the basic API. There are other methods, but these are the core ones to when you're writing checks. What we have found is we could create some other convenience methods for our custom checks. So I have here two of them. We saw the fully qualified class name, package name before, but here are other two. We have one, it's in that super class that we are using for the checks. This one is find all ASTs of a given type. So I give here the token where I am at, and the type, it's going to look, it's a recursive method, which is always fun to code. It's going to go down all the way, the entire subtree, looking for tokens of a given type, and it will find, return a collection. So let's say you found a method, and you want to know, inside this method, is anyone calling exit, which is a problematic method in Java to exit a program, if you're on a web server, for example, right? So you found a method, and you can look for all identifiers, and you may check if any of them is exit, right? Find first AST of a given type, similar to this one, but this one returns only the first one, okay? So two methods that complement the basic API. All right, so let's take a look the next check. Our second check, this is the last check we're going to work with. Check HTML action extends HTML action support. This is the name of the class, okay? Here it is, same structure, extends custom check. Here's the violation message. I am saying, what token do I need to look at? Look, the rule here is an HTML action should extend HTML action support, right? So the only token I need to look at is the class declaration. Why? Looking at the class declaration, I can see the name of the class, and we already have that convention. If the class has HTML action as suffix, right there I have an HTML action element. So then I need to check the extends clause. So you may ask, so Paulo, don't you need to wait for the extends token? Yes, you could, but look, because class definition and extends are right next to each other, once you have the class definition, if you identify that the suffix is HTML action, you just navigate to the extends if there is extends, and you check the superclass, right? It must be HTML action support, right? So only one token of interest. So here's visit token. This is kind of a safe programming, so I still check the type. It's a class def. If it's a class def, I visit class def. And so all the logic from our check is here. Class name. So we found a class definition. Let me get the class name. So I look for the first token that is an identifier. How do I know which token to look for? Just go back to our GUI. So where's the class def? It's here, right? And it's here. If you look at the structure, class def is the first token. What do you have underneath? You have modifiers, public, abstract, right? We're not interested in the modifiers in this check, but in this case it's just public. What do you have after that? We have the literal, the keyword class, and then we have the name of the class, error mapping. Okay, as I click here, it's highlighted here. The name is what? It's an identifier, token types dot ident. So that's the token. Under class def, it's a direct sibling. Oh, child, sorry. It's a direct child of class def. That's ident. So I look for the first ident. It has to be the class name. If that class name ends with HTML action, there you have it. We found a special architectural element which is an HTML action. Let's see if it follows the constraint. Does it extend the method it's supposed to? So I have here a separate method, extends HTML action support. It's down below. So how do I know? I have to look at the extends token. Look, I am at the class def token. How do I get the extends token? Find first token that has that is extends clause. Again, you just look at the tree. So in the class def, where's extends? It's right here. So you found extends. Now extends what? Go ahead.
So you just opened an arbitrary class.
Yes.
Try to understand what the symbols mean.
The structure of the tokens, yes. Good question. Can you do this for other languages? CheckStyle is only for Java. There's another API that you can use. I'm going to mention it soon. It's SonarCube API, and that one has other languages. I actually listed them. Okay, but the idea is similar. So you're looking at extends, right? And you want to know what class, superclass you're extending. How do you find out? Double click here, it's going to expand that tree, and you're going to see there is an ident. That's the superclass. You see, this is the name of the superclass. So going back to the code, all I need to do is I find the extends clause. If it exists, then the superclass will be the first child. That's the identifier. Okay? Because in Java, when you say public class XYZ extends something, that something is the name of the superclass. Okay? So our first child is the name of the superclass. And then I just check, is this superclass HTML action support? If it is, return true. It means it is the extends is as expected. So I can go back here. If it returns false, then we have a violation. And it's going to report the violation that we listed here, saying HTML action classes must extend HTML action support. Okay? Is it too, am I going too fast? Can you follow the logic? Okay, great. So here's a challenge to you. There's an exception to this rule. An HTML action class doesn't need to have that superclass as long as it, instead of having a superclass, it implements a given interface. What interface? HTML action. So if instead of the extends HTML action support, it implements HTML action, that class is okay. So that's the exercise, and it's listed on Notepad. Exercise number 3. Any questions? Okay. So it's reminding us you have to uncomment this other check in the custom checks XML file. So it is right here. This is the second one that we are working with. So I'm going to uncomment it. Now it says, build and run the new check to analyze the Adventure Builder project. Something just happened over there. Oh, it was before. Okay, where's my backup? There you go. Notepad is practical, but it's risky. So, yeah, so. First thing we're doing is running the check, okay? And there are no violations at this point. And here it says, this is actually not quite accurate. There's a class called catalog HTML action.java in the target code base. Yeah, this is not easy to do if you don't have the IDE, but let me do it here real quick. So this is an exception to the rule, and as you see, it says to be renamed. Okay, so to make it work, to become a violation, we need to rename it, because the name that you see here doesn't make it an HTML action, right? It has to have that suffix. So if I comment this line and uncomment the other one, now what do we have here? Catalog HTML action. Hey, that's an HTML action. And implements HTML action. That's the interface. So, but it doesn't extend HTML action support. So if I simply rerun, I don't have to build anything, but simply rerun, it found that violation. So catalog HTML action.java, and it says HTML action classes must extend HTML action support. All right? So how can we fix this? We need to edit the custom check and look for the implements statement. And you may, okay, so where am I looking for? What token? Again, you go to the tree. And this one has implement. So the class definition has implement somewhere. There it is. After implements, you have an identifier. Okay? And we know in Java you can implement several classes, right? But the list of classes, they're all identifiers. So all we need to do is let's look for an implements token and then get all of the identifiers in there and see if any of them matches HTML action. If they do, that class is good. All right? So if I go over here, no. I was checking for the extends in this method. Let me create another method, Boolean implements, okay. Implements HTML action. It's going to return true if it does implement HTML action. IDEs make us lazy. So we have a class def token. We need to get an implements token. So that's the class for tokens. Implements token types implements. You can even double check. Is it an implements clause? Yes, it is. Implements clause. That's the name of the token we're looking for. All right. Now we found an implements token. If, well, we may not have found any, we may not have implements, so you need to check. Now you need to get all of the identifiers, okay? Find all ASTs of a given type under our implements token. What type? Token types dot ident. List has become ambiguous. So I have the list of identifiers. If, remember, ident is a token, so to get the text corresponding to any token, just do get text. So the right way to do this is actually like this. Find all, yes. Return true. So does it make sense at this point? Okay, this is we're doing this too fast. I understand, but my goal is for you to understand how simple this is. Once you get a hold of the API, right? So let's see if it works. Last time we executed this, there was a violation. Hopefully it's going to go now. No, it's still there. Oh, of course, we created the method, but we didn't check. Yeah, so implement's okay. Now, we need to check. All right. See, if it doesn't have the extends or the import, ta-da, it went away. So the custom checks are quite simple programs, but they're very powerful and they're very quick. So we can run this kind of check in a large code base in sometimes seconds or minutes. And it turns out that we have realized, this is one lesson we learned, these design constraints or architectural rules can be easily expressed in syntactic terms. Testing. Because we need to run CheckStyle to make sure that the custom check works, our unit testing, our automated tests for this kind of program are more like integration tests, more than unit tests. They're kind of comprehensive. They're more complex. Okay, we need a special runner that runs the CheckStyle engine, gets a test file as input, parses that file and verifies, asserts that you find the violations that you have in the input file. Okay, so I'm going to quickly try to give you a sense of how it works. And that's the reason I didn't start with the JUnit test, because the test harness for this is not that simple. But the basic idea is this: you need to create an input file, which is a .java file that has violations in known locations. And known locations, I mean the line number. And then you check the output of the analysis if it found the violations on those locations. Okay? And also you can check for the lack of violation reporting. So let's take a look. And I have here source, and the source test Java. I have a check HTML action extends HTML action support test. That's the last check we worked on. And we have a method that says test. Okay, but that's how we named the test methods. Test when HTML action has no extends or import. Look, it doesn't look like your regular JUnit test, because first off, it extends this class. That's part of the test harness that we have that hooks up with the CheckStyle engine, okay, that consumes an input file. So everything is set up. It is, underneath it's complicated, but for you it's simple. We have this kind of boilerplate JUnit test code. So you declare the check class, that the one that you're testing. This is boilerplate. And then you list the violations. So we are expecting a violation in on line 13. Where? In this file. Look, this is the input file. Input check HTML action extends action test.java. And that file is under here. Source, test, resource. It could be anywhere, of course. Okay, this is for the program. It's just an input as a string. Okay, and you see there's the class. It doesn't have either extends or import or implements, so there's a violation here. By the way, down below we have another class in the same file. It extends HTML action support. So I'm also testing that when there's a class with a proper extend, there will be no violations. So I indicate what's the input file, and I call verify. Now, how do we run this test? Well, we could run it here on the IDE. I hope it works. It did. It's green. Always good to see that, especially when you're giving sort of a demo in front of people. But here's the thing. We are building our project using Maven, and unless you specify every time you build with Maven, as it's set up at least, it will run the tests. And that's actually what we're doing so far. So here, tests, it's running the test and it's passing, okay? So that's working, but we can do better. So here I have exercise 4. This is the last thing we're gonna do, and then we're gonna jump into the rest of the discussion. It says, okay, there's a method in that test class, which is test when HTML action has import. We want to check that specific situation. And the steps are on DontPad. Exercise number 4. So that's the test class. It's asking you to enable the first test. We already did. We can build and run. And now we need to enable the second test. Which is disabled. Now it's enabled. Look, there's no coding to be done. The test is already written for you. If you want to play with this, homework assignment here is asking you to make the test for the other custom check work. And over there you have some coding to do. But for this one, all it's doing is it's asking you to take a look at the input file. Look, input, this is the file. It's test2.java. It's right here. Let's open it. And here, going back to the slide, it says it should test that a class that imports HTML action doesn't report a violation, right? This input file is not okay. What's missing? The implements in this case, right? Implements HTML action. Oh, here's implements. Typo. I only have this to show you this other method here in the code of the check, of the test, I mean, which is this. Look, typically you're going to have a collection with the expected violations. What if you want to test an input file for no violations? And in this case, you use this other verify method here. Verify audit done with 0 errors. Audit done because that's the output in the std out, so that's why we use that name. But anyway, so if I just build, it should run both tests now. But there's a build failure. Oh, I know. What did I do wrong? Didn't save. Mm-hmm. Tests. What now? I know. Looking back at the slides, HTML action is capital HTML. That was a test. Build success. But, yeah, so you saw that if HTML action were not there or were misspelled, we would have a violation. The test would fail. folks, I know this is kind of rushed, but the API is simple. I hope you, if you're interested in building this in your organization, you get enormous value out of this. And you can then play further, and you can send me an email if you want to keep the exchange. So let me go over my final slides with some other comments that are relevant to make all of this work. So one thing that is very important to do with these custom checks is to integrate them into your SonarQube analysis. And you can do that. SonarQube is a pluggable platform, so you can create plugins for SonarQube. SonarQube comes out of the box with several plugins that analyze your code for many different things, but you can then throw in your own plugin with your custom checks, right? And then when the analysis is done, violations are reported. And you can, so when you build the plugin, it's just configuration, you can indicate, oh, this custom check is a blocker, is a critical or major minor. You can give an error message and so on. Classify the violation, okay? These kind of things have been changing as the SonarQube platform is evolving. But the point is, it is a good practice to encapsulate your custom checks in as a SonarQube plugin and run them in the analysis. And of course, it's a good practice to run SonarQube analysis in continuous integration, right? Periodically, as you build. So that's one thing about SonarQube. That's having your custom checks in the analysis platform. The other thing is, instead of CheckStyle, you can use the SonarQube API. There's also the PMD API. We have used it, but mostly to parse XML files, okay? And we actually, years ago, we contributed to the project, the open source project, the PMD open source, with a plugin to parse WSDL files, right? We still have those around. No new ones, but still have those. And here's the thing. Should you use SonarQube API instead of CheckStyle? Now, I'm not affiliated with any of these products. I'm going to give you my perspective as a developer, and it's not my personal perspective. It's our group. We discussed this. Well, it depends on how much of your analysis is kind of tied to SonarQube, because unfortunately, there is competition among these static analysis tools. Although they are all free open source, well, there's natural competition. I actually, one day I was kind of upset, and I mentioned in a forum, so it looks like SonarQube is at war with these others, and then someone from SonarSource replied, no, this is not war, this is competition. And SonarQube platform has been evolved, and as such, these other tools are being deprecated, and support for these other tools is not evolving with the new versions of SonarQube. So at this point, for example, if you build a custom check with CheckStyle, you can run it like I did. You can still package it as a SonarQube plugin, but for example, you cannot run it on SonarLint. I am very glad that here in class we have someone from SonarSource.
I just want to point out that the CheckStyle SonarQube plugin has been taken over by the folks who run the CheckStyle project, and they are releasing very frequently with new versions of CheckStyle. The PMD plugin, on the other hand,
Sure, everybody can hear you. That's the only mic I had.
Okay, so I want to point out that the CheckStyle plugin has been taken over by the maintainers of CheckStyle itself, and they're releasing on a very regular basis, embedding new versions of CheckStyle. On the other hand, the PMD plugin, the maintainer that's taken over that project, just put out a call on the group to say, hey, is anybody using this? Is it worth updating it? So if you're using it, weigh in.
So, yeah, but the main issue here is not to use the CheckStyle plugin, but support for you to create your plugin with the custom checks with CheckStyle. But anyway, so there are these two options. And so we discussed this. And here's a comparison of the CheckStyle API and the SonarCube API, because this is an important decision if you want to create these kind of things. And I tried to label the versions here. I didn't use CheckStyle 7 because it requires Java 1.8. But look, first, JUnit support. For CheckStyle, it's complicated. You need that test harness in place. In that Git project that you have on Notepad, you have that set up for you. So the unit test looks simple, but we had to do a lot of things to make that work. With SonarCube API, and remember here, I'm not talking about SonarCube, the product, the platform for code analysis. I'm talking about their support to create custom checks or custom rules, okay? For that, and we are creating lots of new checks using SonarCube API. It's much easier to test, JUnit testing. And here's that complaint that I had, that I voiced. No SonarLint support for CheckStyle. What's SonarLint? That's it's a plugin for your IDE. So if you have IntelliJ, or if you have Eclipse, you can run the checks locally. No need to then analyze the whole code. It's integrated with the editor. Here's something that we miss dearly in the SonarCube API. There's no GUI program to visualize the syntax tree, like we have the GUI main that I showed you in CheckStyle. Why? There's a technical reason. And it's something that we also miss in the SonarCube API. So the CheckStyle API has that class, DetailAST, that gives you full access to the syntax tree. You can get even comments, okay? Everything. For the SonarCube API, as I'm an outsider, so my interpretation is they decided to create an API that would be simpler. And how did they do that? They created multiple kind of AST types, different types, for the different tokens. Instead of a single type like we have DetailAST, they have like a package declaration token, they have a method declaration token, a package, an import token, and so on. And for each of these specialized token classes, they have convenience methods. So if you're in a method declaration token, there's a method that gives you like the parameters. See? So it's simpler. However, it's limiting when it comes to create your custom checks, because if you have full access to the entire AST, you can navigate everywhere and check those more complicated rules. With the SonarCube API, you can't easily navigate the entire tree because you're kind of limited in the navigation to the convenience methods there. We have tried to port some of our custom checks from CheckStyle to SonarCube, and we're facing this problem as we speak. So another complaint that I have is that the Java API is reasonably well documented for CheckStyle. For SonarCube API, well, they have generated like the Java docs in HTML, but they're empty. There's no prose. And if you go, I remember the first time I was looking, they have something called the symbol, the semantics side of the analysis, and there was a class called symbol. And it was, what is a symbol? It's a core concept in their API, but there isn't a single phrase saying what's a symbol. But anyway, it's an open source project, so you can always look the code and find out. Nice thing about CheckStyle is that you can run it using command line. That's what we have been doing.
I do have a question about the open source. API is an open source, but there are companies basically selling support and selling add-ons as well. So this is where the open source thing gets confusing.
But yeah, but many open source projects are like that.
Right, absolutely.
Right? Yeah, so they have to have some business model, and yeah, I think that's more than healthy. But anyway, so technically we can run CheckStyle on a command line. That's what we have been doing here. For custom checks created using SonarCube, you cannot do that. You have to run the analysis through SonarCube. So you need to have a SonarCube platform installed on some server. It can be local, on your local machine, but you need that web server infrastructure with a database, and then you run the custom check on SonarCube, and it reports to that database. So to run a simple check, it's more involving. Now, another nice feature that we have with CheckStyle, it has a an output which is an XML format. So if you want to report, and we have created these reports, we had a code base and we created some checks for important checks, and we generated this report in XML. We created an XSLT transformation. We rendered them as HTML, very nice, and we sent them to managers of the development teams with lists of kind of blocker errors that they were supposed to fix. And we were keeping track. Every month we would generate a new version. So this reporting capability was very handy in our situation, and we don't have anything like that for on SonarQube. Of course, you can go to the SonarQube dashboard and see the results, but yes, but the dashboard shows everything. You can filter, but it's not like you can easily get like an HTML report with only those things that you're concerned with and send them via email, for example. And here's a major difference. CheckStyle can only analyze Java, whereas the SonarQube API, it is in Java. There is a SonarQube API in Java. There's one, it's not a programming API, it's more like for XPath syntax that even goes beyond, but they have support for other languages. I listed them here, and it's probably growing. Yeah. But the thing is, it's polyglot, right?
It could be useful if you do a lot of legacy maintenance, especially offshore.
All right, so wrapping up a little bit of our experience at ECU. This is our process. Just to give you an idea, we were focusing on specific custom checks. But the idea is, first you're going to envision some design constraint, right? So you thought, okay, I have a layered architecture. Classes in this layer cannot call an upper layer, a given specific upper layer. So you mentally specify the rule, and then you translate that into syntactic terms in your target language. So you implement a custom check, and we run that custom check over the code base. Guess what? You're going to find a lot of false positives, okay, or exceptions that you decide not to fix. So you're going to iterate here up until your conformance rule is good to go. And then there's a question that you need to ask yourself. If you have a custom check and that reports violation, and there are, say, 50 violations in the code base, can you fix them? The best scenario is when you can. So you're going to go on and fix the violations, okay? And then when you're done, at that moment you should enable that custom check in SonarQube analysis, okay? You cleaned up the house, and now you keep it in the analysis. Remember on Tuesday I mentioned a mechanism called a pre-commit hook to GitLab or SVN server, like a safety net. It's a last measure of defense to avoid these problems to creep up. So if that is a kind of must-follow custom check, you can enable that in the pre-commit hook, okay? When you say, oh, there are 200 violations, we can't just fix it. Well, what our policy is, we just enable it in the SonarQube analysis, and it will be reporting those violations. The projects will lose points in the quality index, but then those lost points are incentive for the project manager to allot some time to fix those violations. So we have created 50-some custom checks for different categories of things. Architectural conformance, as I mentioned on Tuesday, they're very simple to implement to enforce your layered architecture, okay? Which is kind of a basic layer foundation for these kind of systems at least. You can also check for the proper placement of UI, data access logic. How? We can imagine. Let's say using Hibernate. It's a framework for object relational mapping. Well, you know what are the packages that you need to use Hibernate. You don't want them in the presentation layer. Just look for imports of those packages or references to those Hibernate packages in code that belongs to the presentation layer. It's that simple, okay? Mandated generalizations like we did for HTML action, okay? Naming of software elements, proper use of util modules, design standards that you set up for. We have several design standards for REST. We use REST controllers, Spring MVC, so we can enforce several of these standards in the implementation. we can use for proper coding. And this is similar to the built-in checks, but sometimes you have more specific rules for coding, and you can create some of them using custom checks. I listed some of the things we have used it for. Application security. Also, you find these kind of things in your built-in checks that come with the tools. But here's an example, hard-coded passwords. Well, the built-in checks that come with the tools, they already look for that. Like you say, private string password equals, quote unquote, XYZ. That's a security violation because someone can decompile code and find out. Well, years ago we ran a proof of concept project with a tool called Fortify, and then to spot these kind of problems, and we had these problems. But the tool, which costs hundreds of thousands of dollars, didn't spot hard-coded passwords in our code base. Why? Because we don't use the word password. We use the translation in Portuguese, which is senha. So we had private string senha equals XYZ, or contrasenha. So that's when custom checks come handy, because then you can check for your words, right? And other things listed here. So few lessons learned real quick. You should add your custom checks to SonarQube analysis. Add analysis in continuous integration, of course. We use Jenkins. Follow architecturally evident coding style. Even if you don't know custom checks, it's a good practice. Let the developers know about this because they can engage, okay? And open space for suggestions. That's a good thing. And be careful not to become the architecture police. This is one initiative we have, but it's quite flexible, okay? But we do several other things so that they look at us and they can see that we are actually helping everybody to understand the architecture, okay? We didn't see that, but you should create a mechanism to easily trump a check. There will be exceptions, okay? And another thing, automate the way violations are reported to developers. And so a quick example was that email. So the pre-commit hook sends an email with further clarification about an error when someone gets has a commit attempt denied. We had that, and people began to complain because we were sending, the architecture team would send, hey, you tried to commit this file, here's why it didn't work, here's how you fix. Because we personally were sending that email, people got offended. And then realize, oh, it's because it's not automated. If Jenkins tells you that you broke the build, you're fine with it, right? In Brazil, you go to the ATM to draw money, he asks for the PIN code, and then he asks, what's your mother's maiden name? What month were you born? And you answer and you get your money. If you go to the teller and say, I want to withdraw $100, and the teller looks at you and, what's your mother's maiden name? You're going to feel offended, right? So automate the communication, reporting something that someone did wrong. That's a lesson learned hard way for us. So here's some links for more information. My email address. Please follow up with me if you want to try this. I can give you some more hints and share more code and everything. And this is it. Any questions? Thank you. Thank you. Oh, Joe.
One thing I really like you said is it's not meant to be like the architecture police.
Yes.
But more like architect mentors, which I like. But have you also found it useful, at least with all the work you've been doing, because I know you've been doing this for quite a long time, to also be a feedback loop to the architect that, oh, people are having to override this rule a lot. Maybe there's a problem with the architecture that we need to evolve or refactor. What's been your experience with that?
So what we have been doing is everybody who's creating design at this point knows about this, the custom checks, and they have kind of engaged in this idea, and they come to us and say, hey, I have a new design rule. Can you implement it? Implement a custom check for us. The ones that make it to the analysis are the ones that are quite stable. When things go in a different direction and a design rule is no longer a rule, we just go back and change the custom check. It has happened. So
But I'm not saying change the custom check, but also change the architecture. Because now you're getting a lot of feedback.
yes, yes. Oh, definitely, yes. Yeah, so as our architectures evolve, what happens is we actually have a categorization. There are custom checks for we have reference architectures back home. So we have in their version, we have custom checks for this version, for this other version, for this other version. So that has happened, definitely.
Of course, you may also want to consider changing your developers, but that's a different.
All right, so we should all enjoy the short break this time,
Yes.
and then head to the auditorium. We have a nice keynote awaiting.
Thank you
all.